All right, we're going to talk about asymptotes. Asymptotes are lines that your graph approaches but doesn't actually hit. Think about a wall. If you have a wall, a vertical or horizontal asymptote, and your graph comes up to it and then kind of curves, and it'll get closer and closer and closer, but it never actually touches or crosses, usually. There are some rare exceptions, but for now we'll just get into the concepts of the horizontal and the vertical asymptotes. I want to start with a horizontal asymptote. For horizontal asymptotes, the equation of a horizontal line is the equation y equals a number. To discover what that number is, what we're going to do is we're going to compare the powers. For horizontal asymptotes, there are 3 rules as to how to come up with what the horizontal asymptote is. So, the first rule says, if the numerator is less than the denominator, what we're talking about is the powers, the highest. Actually, we're talking about the degree of the polynomial. The degree is the highest power that you see. In this lesson, we are only dealing with one variable, so we can just say it's the highest power. If the numerator's power is less than the denominator's power, then you have a horizontal asymptote at y equals 0. Automatic, you don't have to do anything. You would just find that it is automatically y equals 0. But if the numerator's degree is equal to the denominator's degree, then what we're going to do is make a fraction out of the 2 coefficients. The leading coefficients are the coefficients of those highest power terms. So, for example, if I had f of x is equal to 2x plus 4 over 3x minus 7, the power is 1. The power or degree is 1 for the denominator, so they are the same. So since the power or degrees are equal, I'm going to take the fraction of the coefficients. So I know for a horizontal asymptote, I'm looking for an equation, y equals, so it is y equals 2 over 3. If the numerator's degree, or power, is greater than the denominator, then you don't have a horizontal asymptote. You actually will have something, or you may have something called a slant asymptote in certain situations, but that's not horizontal, so we're not going to worry about that right now. All right, so here are 3 rules. We're going to compare the highest power of the numerator with the denominator. If the numerator is smaller, it's y equals 0. If the numerator and denominator are the same power or degree, then you take y equals the coefficient of their degree terms. And if the numerator is greater than the denominator, then you do not have one. You can just write none. So let's try some examples. F of x is equal to 6x squared plus 7x over 2x squared minus 3. I'm going to look at the powers. This has a degree of 2. The denominator has a degree of 2. They're the same. So since they're the same, I'm going to take, I should use a different color, the coefficients right there, 6 over 2. My answer is, I'll keep with the red, y equals 6 over 2, or y equals 3. And there is my horizontal asymptote. So let's try number 2. The degree of the numerator is 3. The degree of the denominator is 1. Since the numerator is larger, I have none. No horizontal asymptote, so I'll just write none. And then I have a degree of 1 in the numerator, a degree of 2 in the denominator, and so since the numerator is smaller, numerator is less than the denominator, I automatically just write y equals 0. Okay. Once you practice a few of these, the rules will start to become a little bit more clear and not very difficult. There's not a lot of work that you're going to have to do. Vertical asymptotes, however, are based on a completely different concept. The vertical asymptote, now think of a vertical line. A vertical line has an equation, x equals a number. So what we want to focus on is what makes the denominator equal to 0. And that's where your x is. So we want to look at the denominator. I have a problem with x being a positive 3. If x is a positive 3, 3 minus 3 would give me 0, and you can never, ever, 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 ever have 0 in the denominator of a fraction. So I'm going to use green, since I already have a bunch of red on this one, and blue. So I want to find my vertical asymptote. My vertical asymptote is a line x equals a number. Now what is x not allowed to be? 3. So x equals 3 is like a wall. It's a vertical asymptote. Now, in this one, I'm going to have to do a little work first. I can't tell right off the top of my head what is going to make that denominator 0. So first I better factor it. So let's see. X squared plus 7x plus 10. What two numbers multiply to give me 10, but add up to 7? And the answer is 5 and 2. And it's a positive 7. So I have plus signs in here. All right, so now what makes my denominator equal to 0? When x is, remember the bad teenager analogy, negative 5, and x equals negative 2. Remember, an asymptote is a line. 5 is not an asymptote. X equals 5 or y equals 5 is an asymptote. So please make sure you don't just give me a number, that you give me the entire equation of the line. All right, and for the last one, what value of x would make that denominator 0? It's funny how sometimes the easiest ones can trip you up the most. When x is 0. We can't let x be a 0 because that would give me a 0 in the denominator. All right, now, a hole in the graph is very similar to a vertical asymptote. A hole in the graph is when the numerator cancels with the denominator. A factor of the numerator or a value in the numerator cancels with a value in the denominator. For example, I see right here x plus 4s will cancel. I want so badly to say that x equals negative 4 is a vertical asymptote. However, since they cancel, it's only temporarily an asymptote, I guess you would say. So it's not a full asymptote, it's just a little hole in the graph. I'm still never allowed to let x be a negative 4, but since it cancels out, it's kind of gone after just a few seconds. So I would say I have a hole at x equals negative 4. Okay, now let's look at this one, because this one's a little different. I know for a fact x is not ever, ever, ever allowed to be 3. And x is also never allowed to be negative 2. Okay? However, since x plus 2 cancels with the numerator, it's not a vertical asymptote. It is a hole in the graph. But x minus 3, or x equals 3, is still there, so that one is a full-out vertical asymptote. All right, let's look at my options here. X times x minus 5. X is not allowed to be 5, and x is not allowed to be 0. Okay, 0 times anything would give me 0. 5 would give me 0 for the second value. These two would be normally considered vertical asymptotes unless one of them can cancel with the numerator. And actually, the x can cancel. The x minus 5 cannot, but the x could cancel with one of these x's. And so that would make this one a hole in the graph, and this one a vertical asymptote. So just be careful. When you're doing horizontal asymptotes, you have to look at the rules. Okay? We're looking at the degrees. HD, we're looking at, or HP, I guess you would say. HP, we're looking at the powers. which is also the degree of the polynomial. So you're looking at the highest powers and comparing them. For the vertical asymptote, we're looking at the denominator. Okay, we want to know what makes the denominator equal to 0. And you just have to be careful that once you decide what makes the denominator 0, you have to decide, is that value going to be a vertical asymptote or a hole in the graph? And it all just depends on if it was able to cancel with the numerator, like that did here. All right? Good luck with those. All right.